Have you ever wondered why every seat on a commercial aircraft faces forward? Rear-facing seats are actually safer in a crash. The military has known this since the 1950s and still uses them today. So, why don't commercial airlines do the same? If you've ever flown on a military transport aircraft, a C-130, a C-17, or almost any other military cargo plane that carries personnel, you'll notice something immediately. The seats line the walls and face backward, toward the tail, away from the direction of travel. Soldiers, paratroopers, and military passengers have been sitting this way for decades without complaint. The physics behind it are straightforward. In the most common type of survivable aircraft accident, a rapid deceleration on impact, a rear-facing passenger is pushed back into their seat. The seat absorbs the energy. The body is supported across the entire back, shoulders, and head simultaneously. A forward-facing passenger experiences the opposite. The body is thrown forward against the seatbelt, which concentrates the deceleration force across a narrow band at the waist. The head and upper body continue moving forward until the belt arrests them. The forces involved in that motion are what cause the majority of serious injuries in survivable crashes. Multiple studies by aviation safety bodies, including the FAA, have confirmed this. Rear-facing is safer. The data is not disputed, and yet every commercial airline in the world still puts you facing forward. The reason involves psychology, economics, and a calculation that airlines made a long time ago and have never had a strong enough reason to reverse. To understand why rear-facing seats never made it into commercial aviation, you have to understand how the industry makes decisions about cabin configuration. Aircraft interiors are not designed purely around safety. They are designed around a combination of safety requirements, passenger psychology, operational economics, and certification costs. And when those factors conflict, the outcome is rarely the one that pure safety data would produce. The rear-facing seat problem has three distinct layers. The first is passenger acceptance. Airlines have tested rear-facing seating in commercial context going back to the 1960s. The consistent finding was that a significant portion of passengers actively disliked it. Motion sickness rates were higher in some studies, particularly in passengers who are prone to it, because facing backward removes the visual cue of moving towards something, which the inner ear expects to match with what it feels. Beyond motion sickness, there is a psychological discomfort that is harder to quantify but consistently documented. Passengers reported feeling more anxious, less in control, and more uncomfortable facing the direction the aircraft had just come from. For an industry that is already managing a significant portion of the population's fear of flying, adding a seating configuration that increases passenger discomfort was never going to be an easy sell. The second layer is commercial. Airlines operate on extremely thin margins. The configuration of a cabin is one of the few variables they can control to maximize revenue per flight. Rear-facing seats in their most structurally sound form require a different seat frame, different attachment points, and different certification testing than forward-facing seats. The entire supply chain for commercial aircraft seating, the manufacturers, the testing protocols, the maintenance procedures, is built around forward-facing configurations. Switching would not be a modification. It would be a rebuild of an entire supply ecosystem with certification costs running into hundreds of millions of dollars across a fleet. The third layer is regulatory. Aviation authorities certify aircraft and cabin configurations through a specific testing and approval process. A rear-facing seat configuration for a commercial aircraft would require full certification, dynamic sled tests, occupant protection analysis, emergency evacuation trials, carried out for each aircraft type it was installed on. No airline has ever had a commercial incentive strong enough to absorb that cost voluntarily. Here is the part of this story that almost nobody discusses. The safety advantage of rear-facing seats is real, but it is not as large as it sounds when you apply it to the actual accident statistics of modern commercial aviation. Commercial aviation has become so safe that the scenario where rear-facing seats would make the biggest difference, a high-energy forward deceleration crash, is extraordinarily rare. The vast majority of fatal commercial aviation accidents involve impact forces so severe or fire and structural failure so complete that seat orientation makes no meaningful difference to survivability. The accidents where seat orientation matters are precisely the ones that are already the most survivable: runway overruns, hard landings, controlled flight into terrain at relatively low speed. In those scenarios, rear-facing seats do provide a measurable advantage, but the baseline survivability of those accidents is already high with current forward-facing seats and modern restraint systems. The incremental safety gain of switching the entire global commercial fleet to rear-facing seating, measured in lives saved per billion passenger kilometers, is smaller than it sounds when the headline is "Rear-facing is safer." This is not an argument that the industry made publicly. It is the implicit calculation behind every decision not to pursue rear-facing seating commercially. The cost of switching, financially, operationally, and in terms of passenger reaction, was never justified by the safety improvement it would actually deliver in the real-world accident environment of modern commercial aviation. British Airways experimented with rear-facing seats in its first-class cabin on certain aircraft types for a period. The seats were forward-facing in terms of how passengers experienced them visually, designed so that the passenger faced a suite-style partition rather than an open cabin view, which reduced the psychological discomfort. The structural benefit was partially retained, but even that compromise was eventually phased out as cabin design moved in different directions. The most common misconception is that airlines know rear-facing seats are safer and are choosing profit over passenger safety. The reality is more nuanced. The safety case for rear-facing seats in the modern accident environment is genuine but limited. The accidents where it matters most are already highly survivable. The decision not to pursue rear-facing seating commercially was not made by choosing money over lives. It was made by calculating that the safety improvement in realistic accident scenarios did not justify the cost and passenger disruption of a complete cabin reconfiguration. The second misconception is that the military uses rear-facing seats because it doesn't care about passenger comfort. Military transport seating is designed for operational efficiency and structural simplicity. The seats are Spartan, wall-mounted, and built for rapid loading and unloading of personnel and equipment. The safety benefit of rear-facing orientation is a known advantage, but the military configuration exists primarily because it maximizes usable floor space and loading flexibility, not because military planners ran a survivability study and chose accordingly. The third misconception is that this issue is settled and nobody in the industry thinks about it anymore. In fact, every time a significant survivable crash occurs and the accident data is analyzed, the rear-facing seat question surfaces again in aviation safety literature. The data continues to show the same thing it showed in the 1950s. The commercial and operational barriers that prevent action on that data have also remained largely unchanged. It is one of the more honest examples in aviation of a known safety improvement that the industry has consistently decided it cannot practically implement. So, why don't commercial planes have rear-facing seats? Not because the industry doesn't know they're safer. It does. Not because the physics are disputed. They are not. The military figured this out 70 years ago and never looked back. Commercial aviation made a different calculation, one that weighed a genuine but limited safety improvement against the cost of recertifying entire fleets, rebuilding a global supply chain, and asking hundreds of millions of passengers to sit in a configuration that a meaningful percentage of them actively disliked. In the real-world accident environment of modern commercial aviation, where the scenarios that rear-facing seats help most are already the most survivable, that calculation produced the answer it has always produced. The forward-facing seat you're sitting in on your next flight is not the safest option the industry has available. It is the option that the industry decided was safe enough, given everything else that would have to change to do better. That distinction is worth understanding the next time you buckle in and face the front.